All right, welcome back to part two of this intro to the physics and math section on the MCAT. Today we're going to be finishing up our talk. So last time we talked about these kind of like these high yield angles that we should know. They're probably going to be on the MCAT in the physics section. And today we're going to talk about these things called special triangles. And there's two of them. There's two special triangles. There's what we call this one over here. This is our 45, 45, 90 triangle. And this is what we call our 30, 60, 90 triangle. So our 30, 60, 90 triangle. And these are special triangles because they are one of the triangles where if we know the angles and we know one of the side lengths, then we're going to know all of the side lengths. And I'm going to show you what I mean here. So let's start off with this 45, 45, 90 degree triangle. So the first thing you're going to notice, the very first thing you're going to notice is that two of these angles are exactly the same. We have two 45-degree angles, which means that since the angles are the same and it's the same triangle, the two side lengths are also going to be equal. So we're going to have two side lengths that are equal in length. And then you might look down here and say, hold up, how did we get root 2 times x? So just so you guys know, x, this stands for some variable. It's a variable, meaning it can change. It doesn't always have to be, one number, but it does have to be. So each x has to be the same number. So if it was 1, this x would equal 1, this x would equal 1, and this would be root 2 times 1. So that's what we're kind of looking at here. And you might ask, okay, how did we get here? And that's a very good question. And we used something. We used a little something called the Pythagorean theorem. And I'm sure you guys have heard of this Pythagorean theorem before, but I'm going to just kind of show you the long way on how we got here. So let's draw a totally new triangle. So let's draw a totally new triangle. I'm not the best at drawing, but it's going to look something like this. So this is going to be our right angle here. Let's say this is 45 degrees, and this is also going to be 45 degrees, okay? Since this is just a hypothetical situation, we're just playing around with numbers on our own here, we can set the side lengths. So we can say that, okay, so we know that this side is going to be the same, and we know that this side is going to be the same. So we can just set them to both be the same number. Let's just set them to 1. Because 1's a really easy number, and if we're trying to do math, let's not get too complicated here. So let's make both these side lengths 1. However, we don't know what the length of this side is, so we're going to have to give it a variable. Let's call it c. Let's call this side a and this side b. Now, using the Pythagorean theorem, we know that side length a. So if we square a and square b and add them together, we're going to get the square root of angle C, which means that if we just kind of sub in what we know a is equal to 1, and b is also equal to 1, and they're going to combine to create c squared. 1 squared is just 1, so 1 plus 1 is 2. And that's just going to leave us with 2 is equal to c squared. Or if we were to square root both sides, we can just say c is equal to square root of 2, which is exactly where this square root of 2 came from. Now, we can do the exact same thing with this 30, 60, 90 triangle, but it's a little bit more complicated. I can't lie. So what we're going to do here is we're going to draw something called an equilateral triangle. An equilateral triangle, if you remember, is any triangle where all three side lengths are the same and all the angles in that triangle are the same. So let's draw it out. Okay. Awesome. Okay, there we go. So this is our equilateral triangle. So these side lengths are all going to be the same. This angle, and this angle are all going to be the same. They're going to be, a triangle. The angles within a triangle always add up to 180. So this is going to be 60, 60, and 60. Now, to make this two right angle triangles, to make this our 60, 30, 90 triangle, we are going to split this in half. So we're going to kind of split this in half right down the center, right like that. Now, what we're left with two 30 degrees is here. Remember, we split this 60 degrees into 2. So there's one, there's the other. This makes a 90-degree angle with our base here. And then we're left with a 60 degrees on either side. Okay, so let's draw out this triangle right here. So it should, if I'm not too bad at drawing, it should look something kind of like this. And let's draw a straight line just down there. Awesome. Okay, it should look something like this. And we're left with a 30-degree angle up here, and we're left with a 60-degree angle up there, and this is a 90-degree angle. Okay, so let's fill in the side lengths that we know. Well, we know this side length here, so this is our hypotenuse. It's going to be 2 units. What unit should we use? We could totally use meters, because meters are nice. So 2 meters. This, from our little diagram up here, this is going to be 1 meter, and we actually don't know how many meters this is going to be equal to. And we're going to take the exact same approach as what we did over here with our 45, 45, 90 triangle. And we're going to be left with, we just have to kind of name these sides. So, kind of randomly, let's just call this A, let's call this B, and we can call this C. We know that C squared is going to be equal to A squared plus B squared. Let's fill in what we know. We know that C is equal to 2 squared. A is 1, so 1 squared, and then B is just a big question mark because we don't know that yet. So we have 2 squared, which is equal to 4. So this is going to be 4 minus, well, we're actually going to subtract 1 from both sides because 1 squared is equal to 1. And that's going to be equal to our question mark squared. So we're just going to take our question mark. 4 minus 1 is 3. Take the square root of that answer because, this is a square and we want to get rid of it. So therefore, this side length right here, B is going to be equal to root 3. And we showed that using the Pythagorean theorem. So this is proof. This is our proof. Okay. Now, if you wanted to, you don't have to do this. You can divide every single side by 2. Some people do this. Some people like this. I do it. So now we're left with, so since we all divide by a common number, so every side length is divided by the same number, that means we didn't really transform anything. So we all scaled everything down uniformly. Now we know C is going to be equal to 1. So our hypotenuse is equal to 1. A now is going to be equal to 1 over 2. And B is going to be equal to root 3 over 2. Okay? So let's do an example. So let's see, what color should our vector be today, guys? Let's do this nice red color. So let's say we have a vector right, the vector right here. Vector right here. Okay, we can just call it vector A. Let's call it A. Now, with every vector, let's imagine the question is asking us to break this vector up into its x and y components, and we can do that. So let's say we want to break A up into its y components, so its vertical component, so it's going to look something like this. So we can call this y, vector y, and we can also break it into its x component, which is the same thing as its horizontal component. Let's call this vector x. Okay. So now let's say we're given a bit more information. Let's change our color back to white here. So we're given more information. So we know this is a right angle. Let's say we're also given that this is, let's say this is 60 degrees and this is 30 degrees. So let's say we're given all of this. So we know that just by these words, we know it's a 30, 60, 90 triangle. So we know this is a special triangle, meaning we know what the side lengths are. And let's say that vector A has a magnitude of, well, we can say vector A has a magnitude, just to keep it simple, vector A has a magnitude of 1, just to show you guys how we can use a problem like this to find special angles. Now, we could ask, what is the side length, or what is the vertical component? So the question could be something like, what is the vertical component, what is the vertical component of vector A? So what is this vertical component? Now, a lot of people will freak out and be like, holy crap, I don't know. We're only given one side, so we can't use the Pythagorean theorem, right? Remember, you might think, well, we can use the Pythagorean theorem. We know a squared is going to be equal to y squared plus x squared. So this is our Pythagorean theorem. Normally we could do this, but in this example, we're not given another side length. So we're still left with two variables, right? This is equal to 1, right, 1 squared. But we don't know what these two are, so we can't do that. But luckily, this is a special triangle. So we know that we can use the special triangle properties to solve this problem. And we can just literally just come back up here, go to our special triangle. We know that if the hypotenuse is equal to 1, if our hypotenuse is equal to 1, then what are we looking at here? Our vertical component is going to be root 3 over 2. So it's that easy as vector y is going to have a component of root 3 over 2. And that's all we're really looking at here. The biggest part is kind of getting our heads wrapped around this.